Computational burden, this is the major challenge. So in order to do this, I'm going to just introduce a couple of quantification metrics. So if we have some probability, we have some expected value of that probability. So we have an expectation, just the average value within this distribution. But we're also going to look at things to do with the tail. So when we're looking at blackouts, we quite often care about the worst case. So here I'm going to use, say, the worst 5%. And then what we can do is we can call this the value at risk. So the value at risk for 0.95 will essentially be the value on this axis. So this might have been the amount of demand lost or the number of lines lost. So this will tell me, say, the number of megawatts that will be disconnected for 95, well, for the worst 5%. So the worst 5% of cases will see a loss at least equal to whatever that number of megawatts is. And then there's another value, which is the conditional value at risk, which is just the average value within the tail, the expectation within this 5%. And so we care about these results as well as the expectation. So if we just look at the expectation, that tells us a good representation of the average, but we might be missing information about the tail.